Hello, this is Solar Ed. The Twins Proof of Concept Florida and Michigan Energy Project. TFS Wind and Solar Hybrid Installation Project. The Florida project is known as EPL. The Michigan project is known as MPL. The outside installation process consists of the following: solid signal, 4560 adjustable universal E-mount. Connectivity wireless. We purchased the standard grounding kit, ground rods, copper ground rod with thread. From Home Depot, we purchased the electrical mass conduit, which is 10 foot long, and additional bracing from various other sources. What you see here is the micro turbine installed by the Florida EPL site. Efforts in Florida, the Sunshine State, consisted of a 4-bedroom, 2-bath, 1,800 square foot dwelling. As you can see, they actually installed the micro turbine, solar panel. This right here is a depiction of a same solar panel with additional panels being added. The battery box at the EPL location consists of a pallet, combination plywood painted with handles. The inside mounting of equipment, as you can see, is the control board. This right here was the first set of equipment that was installed for the wind portion only. The mounting board for the watt strip, purchased from Amazon. It's a P3 International P4320 kilowatt power strip. The final mounting board configuration. This particular configuration consists of the wind portion plus the grid tie inverter plus the kilowatt meter and some additional other equipment. Majority of the wind and solar equipment was purchased from Missouri Wind and Solar out of Missouri, Michigan. The inventory purchase consists of an 800 watt Falcon Star wind turbine. You see 12 volt, but typically we started off with a 24 volt system. 3-phase wind turbine cable up to 2,000 watts. The 3-phase brake switch and rectifier combo with associated fuse. The PMA, permanent magnet alternator. Associated cable. You have the cable here and also the disconnect box. Wind turbine locking column. The other equipment consists of a diversion, a dump load. In this case, we actually use the 24 watt one. 60 amp fuse, welding cable, 6x6 gang, aught, welding cable. I believe that's either 1 or 2 aught. The all-in-one charge controller board, which consists of 400 amps maximum and 10,000 watts. Other items purchased from Amazon with a small grid tie power inverter. This grid tie power inverter in many cases was a 500 watt and a 1000 watt. It actually synchronized with the house power. We'll talk about that a little later. Consideration of an Outback power system. We did look at the Outback power system. The basic system started at $3,600 plus other system inventory equipment parts that needed. The other one was Flex 1, Flex 2. Flex 2 is a $5,000 plus associated parts and inventory required to install that. The other location known as MPL, the Michigan Power and Light. Efforts in Michigan, the Great Lakes State, MPL. The particular dwelling here is a 3-bedroom, 2-bath, 1,911 square feet. We also installed the micro wind turbine, 11 blade, with associated panels. There was two 245 watt panels connected in parallel. This is some of the electrical outlets that was installed in upstairs and downstairs and in the bedroom, living room, and also kitchen. This system is independent of the house system. None of the outlets power was tied into the house electrical panel. MPL siting, the micro wind turbine. This was some preliminary information work done to site the turbine. Basically, we had roughly 28 feet from the ground up to the peak to place that turbine. The associated DC cable to the basement control panel, we outlined that general path. The micro wind turbines, there's always a big discussion of how many blade selections, whether you want 3, 5, 9, 11, or 13 blade. The issue comes in speed or the lowest velocity, would you like the turbine to turn. Having lots of blades really gives you the best of both worlds. We selected in the Michigan location a 11 blade configuration. In the Florida configuration, a variety of testing was done on 3, 5, and 9. I believe they finally set it up with 11 blades. The control panel board, that's the MPL location, consists of a controller, DC AC inverter, dump load, grid tie inverter, and some other associated piece of equipment. The control board is another view of it. This board is basically a 6 by 8 plywood board. Battery box. These are the casters used for the battery box. This is the bottom half of the battery box. As you can see, we have the top half with the back. Battery sizing, we actually use 10 marine grade deep cycle batteries. Inside mounting of the equipment, just another display of the control board and the final battery box. MPL all-in-one controller board. As you can see, we got a battery bank, final install, 10 deep cycle batteries, 24-volt system. As you can see, the inside board, all-in-one board, you have your AC/DC power inverter. We have our controller, dump load, fuse, and junction box. Final board configuration. We have our power strip, kilowatt. We have our grid tie inverter. We got our little junction box right here. We have the combo rectifier, the brake, fuse. We have fuse here, and also two of the switches. One switch is turned out power for the inverter. The other one turned out power to the main controller. Final mounting configuration consists of the following. One is a controller. Two is the DC-AC inverter. Three are your two grid tie inverters. 4, dump load. 5, you have your rectifier, your brake. 6, we got another disconnect box. There's another disconnect box here. Number 7 is our fuse here. Number 8, the two shut off switches, one for the inverter power and the one for the battery power. Final mounting board configuration upgrades. We did a variety of upgrades. We add a shut off switch. This is a control switch that actually feeds the grid tie inverters. Also, it feeds a battery, and according to how much power or what you want to feed during the day, whether you want to feed the grid tie for reduced electric rate, or you want to feed the batteries to make sure they top off at the correct 25.2. So that's an extra switch there. The other section over here is a outlet lead we place in. This actually provides power to a auxiliary use apparatus. This is also tied into the furnace, so it's this combination of extra outlet coming off the system. Right now we see the micro wind turbine installation. We did a variety of work trying to make sure that micro turbine is set up correctly. We did a markup, and then we actually went directly up for the installation. Most of these brackets, right, additional brackets, was purchased from Ace Hardware. We had at least 2, but we felt that we probably need to make sure we end up adding some additional brackets. The other installation, you can see the over here to the right. As you can see, we use all those brackets in the previous slide, and typically that installation is good, probably up to 100 miles an hour. Wind load. This is another depiction of we use the JLG 2-man scissor lift to gain access up to 28 feet for the final installation. Solar panel conduit run. We actually had to make a conduit run at MPL. We made a decision to go with the solar panel on a pole out of the exterior garage. We had to do some concrete work, 90 here, and plus we actually came back up here into the conduit into the side wall of the house that connects directly to the control board. Solar panel mounting options. The issue versus roof versus ground mounted panels. In all cases, we went with a pole mounted from the garage versus the ground mounted. It's our personal belief. We don't believe in making penetrations to good rough. So in both our installations, we either go with a ground mounted or pole mounted from an extension, but not a rough detached panels at all. Number of solar panels are required. Energy production. This is the fourth day of installation. I believe August 16th, 2012. We was doing pretty good. As you can see, during the day or early in the morning, the kilowatt output is down. It started rising up around about 10 o'clock, peak around about close to noon time, and then afternoon it started to descent. We believe that our output represents around about 68% of the 490 watts of panels, roughly around 337 watts maximum generated. Now you might look at that wattage and say just all that's generated. That wattage is actually going into the batteries for charging. This is not for producing electricity. Electricity is generated from the AC/DC inverter. Project cost estimate. The Michigan system, MPL system, I estimated cost $7,971.05. The Florida system, $6,323.76. Now, if we compare this cost to a cost of renovating a bathroom, kitchen, the cost in general is quite competitive. Some people like to try to apply a return on investment. Most homeowners, when they buy a house, they actually don't buy a house for a return on investment. Or if they do any improvements, they're not running ROI in that case either. Conclusion. Can this concept work? We believe the concept can work, and with the price between 6 and 10 grand, we believe most homeowners should be able to get a fairly decent system. It's a question of how much bells and whistles you like to add on it. Keep in mind, we're producing electricity, so there's no easy way, cheap way of producing electricity, making an installation to produce electricity. TFS solar generators. Out of the proof of concept, we developed a portable variety of portable solar generators. One is a 1250 watt, which is TFS 1250. The other is 2000 watt. Basically, there's 2000 watts coming out of the system. All these are portable units. U.S. cell coverage. Currently, we end up having solar generators in 25 different states. In the future, we expect to have our TFS new lithium-ion battery packs. Typically, our battery packs, we can use any type of, pretty much any type of lithium-ion battery. Notably is Nissan Leaf battery packs, the Tesla 18650s, the Chevy Volt, and C-Max system can be used in our system.